Welcome to the Bentley Systems training course where you will learn how to design steel connections using RAM Connection Standalone. RAM Connection Standalone is used for the design and detailing of steel connections. It can design individual shear, moment, brace, splice, and truss connection types to a variety of different steel design codes. In this particular video, we're going to be focusing on how to implement the seismic provisions for vertical braced frame gusset connections. In RAM Connection Standalone, you can assign seismic provisions to a column beam brace joint, a chevron brace joint, and a column base joint. And we have both ordinary concentric braced frames and special concentric braced frames available. We will now turn our attention to our RAM Connection Standalone application, where we will be invoking seismic provisions for several different gusset style joints that we've already created. Now, to invoke the seismic provisions for a gusset connection, this will be a several step process. First, you will need to ensure that your design criteria includes seismic provisions. You will need to ensure that your load combinations have been generated to include your overstrength factor. And then you'll need to assign your bracing type and finally assign your connection type. So let's go ahead and start our workflow by specifying our design configuration for seismic provisions. To do that, you'll select your design tab in your ribbon toolbar and then click on the design code icon. Now for this particular model, we've already selected the AISC 16 LRFD design code, and we've entered a maximum strength ratio limit of 1.0. Before we exit out of this dialog, however, we need to ensure that this Consider Seismic Provisions option is selected, and we need to select our seismic design category. We'll select category D for this exercise. Once we're done, let's go ahead and click OK. Next, let's go ahead and take a look at our load combinations for this particular model. So let's go to the Home tab in the ribbon toolbar, and we're going to click on the Generate Load Combinations icon. Now for this model, we've already taken the liberty of setting up several different load cases, including dead load, live load, wind, and seismic, but we have not yet generated any load combinations. Now for seismic provisions, we're going to generate two sets of load combinations. Our standard factored load combinations, considering the code we selected, and we're also going to generate amplified seismic factored load combinations in preparation for seismic provisions. So let's start with our first set of load combinations. This is our standard design combinations. We are going to go with an LRFD version of the code, and we'll click on the Generate option, and we'll click OK to confirm the load combinations that were generated. We're going to repeat this process, and this time we're going to select one of our amplified seismic factored load combinations. You can see that RAM connection assumes an overstrength factor of 3.0 when generating the amplified seismic design combinations. So we selected our load combination generator. Again, we're going to click Generate, and then we'll click OK. And you can see some additional load combinations have been generated and are ready for design. The next thing we're going to do is we're going to create a braced frame system. Now, since we've already selected seismic provisions, you will see a few extra fields available in the joint definition. So what I'm going to do is I'm going to assign one of the joints in my model as an ordinary concentric brace frame and another joint in my model as a special concentrically braced frame. What you're going to see when you look in your calculations is, of course, it's going to include the requirements for each of those different bracing systems when the connection is assigned. So let's start with joint number 1, which is basically a column beam brace style joint. I'm going to edit this joint information, and what you're going to see is, since I have selected seismic provisions, I have a new field available here for braced frame system. For this first one, I'm going to specify an ordinary concentric braced frame. And this system anticipates limited inelastic deformation, relatively simple design, and construction procedures. The design of ordinary braced frame connections is based upon typical steel connection design procedures. The design requirements can be found in the seismic provisions for structural steel buildings, the AISC 341, Section 14. Now everything else in this particular joint I'm going to keep as is. As you can see, all of my geometry has already been created along with my loading information. Once we're done editing our joint and assigning our frame type, we can click OK, and we are ready to move on to assigning a connection. So I'm going to keep joint 1 active. Let's go to the Design tab in the ribbon toolbar. I'm going to click on the Assign option, and let's go ahead and select a gusset option. I'm going to go with a CBB directly welded CBF style joint. Now, if you see, we do have a couple of different joint types with CBF. These would be particular for concentric braced frames, and these are the ones you're going to select for seismic provisions. So I'm going to go ahead and select this first option. A gusset connection is going to be assigned, and let's go ahead and click OK. Once we do that, we can go ahead and edit our connection. Let's go ahead and click Edit, Gusset Connection, and we can review our connection parameters. Now, the first thing I'm going to do is I'm going to go ahead and take a look in the ribbon toolbar and see that my interaction ratio will be indicated. It is in green, so I've passed the preliminary connection design. Now here what I can do is I can also go ahead and edit the connection parameters if I wanted to. I can go ahead and edit all these different interfaces. I'm going to go with the upper right brace. I'm going to go with a gusset to brace connection, and I'm just going to modify this. For me, I'm going to go with a welded connection style, and I'm going to do the same thing for the lower left brace, always being mindful of where your interaction ratio is once you start editing parameters. Okay, everything in my connection looks pretty good. Before we exit out of here, let's go to the results area, and we can review our steel connection report. And here you'll be able to see all of the design check information that was included. So I'm going to go ahead and close out of the report. I'm going to save my changes to this particular joint, and then I'm going to close out of the connection pad. So let's go ahead and move forward to joint number 2, which is our basic chevron brace style. I'm also going to edit this joint. Let's go ahead and click Edit. And then again, for a chevron brace, I do have a framing system I can specify. And for this particular model, I'm going to select the SCBF, which is a special concentrically braced frame. Now, this system is expected to withstand significant inelastic deformation. A special concentric brace frame system is similar to an ordinary concentric brace frame system, but there are some additional requirements in the braces to enhance the ductile behavior in the frames. These special details provide greater energy dissipation and ductility, allowing special concentric brace frame systems to be designed using lower forces than the ordinary concentric brace frame system. The special design requirements are located in the Seismic Provisions, Section 13. Now, everything else in this model, I'm going to go ahead and keep, including all of the joint data and the loading information. Let's go ahead and assign a gusset connection to this joint. To do that, we're going to click on the Design tab in the ribbon toolbar, click on the Assign option, and we're going to go to Gusset Connections. Here, I'm going to select a CVR BCF style joint. Let's go ahead and click Close, and you can see that the gusset system was assigned considering seismic provisions. Now I could go ahead and edit this system again. Let's go ahead and click on the edit option. I'm going to edit my gusset plate, and you can see I can still customize all of my interfaces, again being mindful of this interaction ratio and checking to see if you get any warnings. So here I'm going to go ahead and edit my connection. I'd like to get away with an unstiffened gusset if available. So here I'm going to go to my members area, and you can see I can choose to stiffen or unstiffen the gusset. Looks like unstiffened will get me to a passing connection design. And I'm also going to customize some of my interfaces. So for me, I'm going to choose to unreinforce my section. You can see here it had a plate there. You can see the difference there, a plate versus no plate. I'm going to try to unreinforce it, and instead of bolted, I'm going to try a welded connection type. Okay, that seems to be working all right for me. I'm going to try the same thing for the lower right brace. I'm going to try to unreinforce that bracing system, and I'm going to go with a welded option. So if you wanted to take some additional looks at what that looks like, I'm going to have an angle on either side, and it will be welded directly to the gusset plate. Now, if I wanted some additional information, I can go to the results area, and I could review the connection design. And you can see here the seismic load combinations were checked for the full capacity of the brace, since this is a special concentric braced frame. Let's go ahead and close out of the report. If we like our changes that we've made, I'm going to click on the save icon, and then I can close out of the connection pad. Now, although I didn't invoke that here, a ordinary concentric brace frame or special concentric brace frame can also be assigned to column-based joints that also have a brace assigned to them. At this point, this concludes our process for invoking seismic provisions for gusset-style connections in RAM connection standalone. You can specify your load combinations for your overstrength factor, and you can specify frame types according to the AISC 341.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.